In this tutorial, I'm going to look at a process by which we can get contours from a digital elevation model in QGIS and then move them into Rhino to make a surface out of them and then to project onto them. There's a number of steps. Those steps involve getting the digital elevation model and making contours of it, simplifying it, and then simplifying the contours, then changing the Z a unit for them, creating a boundary to then trim or clip those contours to, then exporting them and some other features to as DXFs to be taken into Rhino. Then in Rhino, creating from curves, extracting control from those contours as curves, extracting control points, patching that surface, splitting it against this boundary that we created to create a more compact patch, and then projecting geometry onto it. So let's go. I'm going to start a new file so that we can go from scratch. And what I'm going to start by doing is by putting in some base material that I want. And so I have one of the key things that I've got, which I want, is that I have a merged DTM, I've called it, but it's actually DEM. So maybe first off, what I'll do is I'll put in a few other pieces. So I'm going to put in the site boundary that we're working with, which for this place called Kenny is what I've called the SA2 statistical boundary. So I'm going to drop that in, and that's there. Now I'm just going to quickly change the properties of it to make it so we can work with it. And so what I'll do is I'm going to make it transparent. Now I'm going to make the stroke color red. And I'm going to put it 2 millimeters on it so we actually know what it looks like. Okay. Then I'm just going to bring in a few other things. So I've got this DEM that I've done, which I'm going to drop in here. Now that's pretty big, so I'm going to move that to the top so we can still see the boundary. Now, it doesn't make a whole lot of sense because it's got some detail that we can't immediately see, but it's there, and I extracted it from the Australian mapping portal called Elvis, which I've discussed in a separate tutorial. So I've got that there, and so what I'm going to do is I'm going to start by taking contours off it. So if I go over to the processing toolbox and I type in contours, you'll see that some come up, obviously my recently used, but don't forget we're working on raster, because a raster is a pixel image and a vector is a line-based point and line-based geometry type. So let's get the contour command up. When that pops in, what it wants to know is what's the input layer. Now it's already figured out that it's the only DEM that's available. Again, forgetting I've called it a DTM. It's one for Kenny. Now it's got an attribute called elevation. Let's just look at that quickly. So if I go to this Kenny here and I go to the attribute table, do I have an attribute table? Yeah, it says load that. No, I'm not going to load it, but what I'm trying to get at is that there is an elevation variable that's available. So let's go back there. So it says, what's the interval between the contour lines? Because we're in meters here, I'm going to make it 1. There's an attribute, elevation, what that attribute is. And let's run it and see what happens. So it's analyzing this from that DEM and it's giving us contours. Now, it's chugging a bit because this is a reasonably large site. But ultimately it will give us some contours. Now you have to be balancing this question about how much detail you're going to need. And so a contour interval of 1 meter I chose because that's more than the current municipal data available for this site in Canberra is. Now, if I'm chugging too much, I could cut it to 2 meters, I could cut it to 5 meters, I could cut it to 10 meters, and they will give less. Essentially, the contours will have less vertices, and that will make it easier to work with. So I close that, and we see that's there. Now, the thing we have to remember is that that's actually just temporary now. So what I need to do is I need to export it. I'm going to save those features as, and at this point, I'm actually going to go to my Kenny folder, but I'm actually going to create a new iteration in it, which is going to be called demonstration, so that we know what we're working with. And I'm going to call this Kenny contours in that folder. Okay. So it says add save to the map, and I'll do that. Okay, so there it is. Now, so I'm going to remove that temporary layer so that we've got just the one I've just created. Okay, so there it is. Now, what I'm going to do is I want to export this and deal with this a bit differently. So what I'm going to do is first I'm going to turn the DEM off because we don't need that anymore. And you'll see that we've got this other stuff here. So let me move some other information in that I want. Let's move in some road edges from the ACT government. So when we move them in, we can see that they're there. Now, I've included them just so that we can get an idea about the context. There's other things that I also want. And so what I'm going to actually also do is I'm going to put in, and this is going to be more complex, but I'm actually going to put in a 1:100 flood model extent in here as well. That's on the top there. You can see where that is. These are all from the ACT government data portal. So it's about finding those right ones. I'm also going to put in the blocks that are currently there. Now they'll come in that sort of way, but I'm going to put them under road edges. And I'm going to just change their symbology a little bit because, you know, they are not physical items. And so let's just go to properties. We'll change the symbology and we'll make it again transparent. And I'm going to make it stroke color in this instance. I'm also going to make it red. I'm going to make it like, you know, it's 0.26, and I'm going to make it a dash dot line like we might see on a survey. Okay. So let me then zoom in to what this is going to look like so that we can get a bit closer and see what we've got in here. So you can see there are the property boundaries, etc. I also have information about canopy cover. And so I've actually cut this up earlier, and so I'm just going to put it in there so that it's there, but you know, where is it? Canopy cover. So we'll put that, you know, it's green, let's make it green. And so properties. Okay. And I'm going to put that on the top layer. So then we have those features in there that we can see, some key features. And so what I also want to do is that I want to, because there's, you know, a lot of contextual data here and there's quite a lot of topographic relief here, what I'm also going to do is I'm actually going to create, I want to also put in land use zoning actually. So there's some land use zoning information. So let's put that in as well. Again, that's going to come in as a whole lot of information. Let's go to the properties. So here we can also say what I'm going to do is I'm going to do categorized, and with a color, you know, want to choose it from this land use description. I'm going to use the color ramp. I'm going to use, you know, this one called Turbo. If we go classify, it gives me all of those. And so what I'm also going to do then is I'm going to try to play with the opacity a little bit so that we can see some more stuff underneath it. Yeah, we can see some more. I might even play with the opacity a bit further so that we can still see it, what the other features are. Now press OK. And there we have those features. I'm going to move those down a bit lower in the stack because I want to have these other features come forward a bit more. Okay, so I've got quite a lot of data there now. So what I'm going to do is I'm going to create this thing called an extended boundary. Now, there's a lot more we can talk about how to create a line, but what I'm going to do is I'm actually going to go and create a temporary scratch layer. And I'm going to call it extended boundary. And then I'm just going to kind of type in boundary here because it's only going to really have one on it. The type of it is actually going to be polygon. I'm just going to, add that to the field list and press OK. You can see there's extended boundary. So now I'm going to draw a polygon. And what I'm doing is I'm really just trying to get a bit broader into the context outside the site, but not all the way up the mountain, because I want to still have the site, the kind of key sort of site information, but I don't want to have necessarily everything, because what we're going to do is we're going to start working with some of these contours and other data. And I don't particularly want to have too much information. So I'm going to right click now, press OK, and we've got that boundary now. Again, let's set some symbology on that. I'm going to again make it transparent because I don't need it to be solid particularly. I'm going to make the outline again. I had it red before. Let's make it blue, and let's put 2 millimeters on that one as well. And let's apply it. Okay, so you could see that that's the SA2 boundary, and then that's this other one. So what I'm going to do now is I want to clip this data back. And I'll need to, once I clip it, I'll need to do it in a few stages. So I'm not going to include all the data for this example. But if I go up here and I choose clip, I should also, what I'm going to do is also I'm going to actually make that, I'm going to save that and export that feature into my folder here. Again, I'm going to call this one Kenny Extended Boundary. Okay. Now, one thing I've got to do make it a little bit sure about, which is what is well, it's mostly in Australia, we want to be using GDA 2020. So let's use that. Make sure that that's right. Add the feature to the map. Again, unfortunately, I've wasted a bit of time there. I'm going to remove that and then restyle that, Don't save. Okay, let's go back and just redo that quickly. Okay, let's go to clip. And clip is like trimming. And essentially what we're doing is we're using it's a vector piece of work. And so if I click on it, what I want to do is I actually want the input layer is what do you want to clip or trim? And in this case, what I want to do is I want to actually, I want to clip the contours. And so what I'm going to do is I'm going to click on that one, the Kenny contours. And then the overlayer is this one, the extended boundary. Okay. So what I'm going to do is I'm going to save to file. I'm going to call it Kenny contours clipped. Obviously, it has to go where I was before, just under demonstration. Okay, save. Now, this is an issue that I have actually had already, which is that when I press save, it didn't actually go anywhere. So this seems to be a Mac issue. So let me do it again. So it didn't actually do it. Kenny contours. It's fine. I'm going to create, just let it create the temporary layer. So there's what the extended boundary, Kenny contours, we run. It sends no spatial index. I don't know why, but I'm just going to accept it. I close that, and we can see that now if I turn these other contours off that we had before, we just have the ones in that site. So what I'm going to do is I'm going to then also name these ones. So I'm going to go export, save features as, go in here. I'm going to call it Kenny contours clipped. Okay, it says add it to the map. Let's make sure that we are there. Yep, GDA 2020. Okay, good. So now I can remove that last clipped one because of the fact that we've already got it. So there, that's been clipped. Now, what I want to do for the purpose of this exercise is that we need to do some things to these contours because at the moment it's 2D representation. So what I'm going to do is I'm going to start by simplifying them. And if you can see, there's one called Vector Geometry Simplify. What we're going to do is we're going to get those contours and we're going to simplify them. They'll come in as a temporary file. So again, I'm going to run this. It's simplified them. It's basically reducing, it's joining them together. It's doing some stuff. So you can see there they are. Oh, so what do we have to do? Well, we have to do the same thing we did again. We're going to save this. And I'm actually going to do 2 more steps before I export it. I'm going to call this one. So that's the simplified contours. Now what I'm going to do is I'm also going to lift their Z elevation. So what I do is I'm just typing in Z. Obviously, that's not a bad place to start. And what I'm trying to do is to find out where we get to the Z elevation. Now, I think it's called Z value. So I click on it. It says, what's your input layer? Well, it's simplified. That's good. What's the Z value? And what we're trying to do is, what we're doing is we're getting to here and we're looking for a field. And as you remember, there was a field in those contours that was called elevation, which we're taking that. And so what we're going to do is we're going to run it. And now we have Z added. Now that's got simplified and Z. So that's good. So we're going to export that and save that. Well, where are we again? Make sure we're in the right place. Yeah. So we're going to call this one Kenny Contours Clipped Simplified Z. So that means that we've now got a pretty good piece of contour material. Okay. It's added to the file. Now I can release these two. In fact, I can release all of those because, I've worked with all those layers. So if I remove all of those layers, then, we just got that one set of contours. I can remove that Kenny contours, the broader ones, because again, I've now got this smaller set. Okay, so it's been trimmed to this extent. Now, a few things that I want to do now. So what I want to do is I want to get those contours out. Now, there's a few ways, and it depends a little bit on the way that the computer will work. And so what I'm going to do is I'm going to start by, I'm going to put all these warnings up here or whatever, get rid of those. What I want to do is I want to export the contours, but I also want to export, at least to explain a few things, these extended boundary and that interior boundary, okay? So what I'm going to do is there is a thing you can do where I'll show it to you actually and show you the issues. I'm going to export these. And what I can do is if I use a right click and I go to export and save features as, then what's excellent about this is that I can then actually export as a DXF. Sounds great, right? There are issues. I'll talk about that in a second. Now, let's just call this one demonstration in my Rhino file. And so what I'm going to do there is that I'm going to save this in that folder as Kenny Kenny contours. Just going to say all, which just means extended, trimmed, whatever, right? So I go save to that. We'll see if it works because sometimes it doesn't. Remember, we've got to check GDA 2020. Layer metadata, sure. Include a Z dimension, yeah, well, we want that. The geometry, we'll just say that's automatic. Add save features to the map, not so much because we really care about it more to take it into Rhino. And then we go, okay. And it runs them and it puts them out there. Now, if I look at them, we'll see, where is it? Let's go to my thing, and there is the Kenny contours all DXF file there, right? Okay, that's good. Now let's get a couple of other features. Well, I think I'm only going to use one feature. Now, what I want to do is also get that export that boundary. I want to show you something that happens to me at least. So let's do it. Let's use the same process. Now, then, again, we're interested in the project, CRS. Here, let's just make sure it's going to the right place. Yeah. And then let's call this Kenny SA2 boundary. Again, this is called that because that's the statistical boundary for the Australian census. Okay, symbology, fine. We don't want to include a Z dimension, doesn't need one. I don't think it has one. We don't do that. Let's go, okay. So what we'll see is that this has come in. So what I'm going to do now is I'm going to go to Rhino. So if I go to Rhino, let's just insert this. So we go to insert or import, and let's go to this contours all and see what happens. Let's just accept all of this for the time being. Says it's successfully read. We can't see it. So let's zoom. Oh, no, it's still coming in. There's a bit of data in there, right? So let's go extents. There's the contours. Let's look in the front and see if they've got some elevation. Let's zoom extents again. Ooh, there's something interesting going on in there. What the goodness sake is that? I don't know what that is. I'm assuming that that's going to be an error. Let's go and have a look at a perspective here. Oh, that's an edge on it, right? So I'm going to get rid of that. In fact, I'm going to go to the top view. And I think that is up here. So I'm just going to delete a little bit of stuff there. Just get rid of it. And let's go back into that perspective and see what's there. There's a little bit still of something in there. So what happens if we do that? We don't necessarily want to do that, but I just want to actually work out what that is. It might not work like that because of this oblique angle. That's now part of it. It's because essentially the edge of that is like that. So I'm just going to clean that up. And the way I'm going to do that is I'm just going to create a line from here to here to here. And I'm going to trim and extend the cutting lines or apparent intersections. Let's see what happens if we just do that. Yeah, that's good. Just so we got rid of that extraneous edge. Let's go back into perspective. Let's go back into front. Looks okay. Right. So we're in the top here, right? So that's good. We've got that in there. That's great. Now you'll see it came in as layer 0. I might want to call that contours. Now, let's see what happens when I bring in the other one. I wonder if it's going to do what I think it is. So let's go into SA2 boundary. Now, one thing to note is that what immediately happened is that we can see that they dropped in different locations. So, I think that tells me that first file, I didn't use the same coordinate system as the second file. So let me try it again. I think that I'm going to use this as a bit of an example. So if we, if we go to here and we go back into this file, and I'm, going to try to come back out again. What I'm going to do now is I'm going to use a different DXF thing. And I'm going to say export layers to DXF. And I'm going to choose, actually just going to choose one layer. Or I'm going to use the SA2 boundary. And I'm going to use the Kenny extended because they're pretty useful. Go OK, and they're in there. Now, use layer title as name. So that's useful to come in there. Again, let's go to, that's interesting. Okay. I think I might have to be careful here because I think I've actually used a few different coordinate systems. So let's actually, let's go in here and actually use, I'm going to, it's not a bad time to look at coordinate systems. So let's just quickly have a look here for a second again. Now, if I go to, when it says unknown CRS at the bottom, what I'm going to do is I'm actually going to click on this one here and make sure that that's okay. Now, this is an issue because I have to re-export things. So I've set that as ESB. So you see it's this one. So in other words, MGA zone 55 is a global one. GDA 2020 is the Australian one. So let's stick with that. Now, I think I'm going to have to do this a couple of more times. So I'm actually going to drop back in at this point to Rhino. I'm actually going to get rid of this file, delete it. Okay, and do that again. So I think even though this is a diversion, it shows you something which is really important, which is that we need to make sure we always use the same projection systems. Okay, so let's export again. Let's use the same process that we did this time for contours. So we export, save the features as. Now remember here we're looking at that. So again, I'm going to check that folder. I'm going to go back in there and say cleaning contours all. It'll want to say to override it. Yes, I do. UTF-8 is fine. Now there's a lot of different sort of ones actually, but I'm going to stick with UTF-8. The scale, let's just trust it on the scale. We want to include the Z dimension, main thing, GDA 2020 MGA to zone 55. I don't need to add them to the map. I run it. Yes, I do want to override it. There it is. So let's do that. Now let's also look at this other layer. So now I'm going to export this one. And, as we said, what I'm going to do is I'm going to go here. I'm going to go to, it doesn't have UTF-8 there. So I'm just going to accept this one. Yeah, let's go to the project CRS, right? MGA 55, layer name as title, Now, I've had an issue with this. So as I said, it sort of seemed to work all right, but I'm going to do it this way, a slightly different way, because I know that I have an issue when I try to do it. So let me put a few layers on there this time. In fact, I'm going to put in select all, except I'm going to take out Kenny contours, clipped and simplified, because that's a bigger file. No, I'm not going to take them all because I haven't clipped all the rest of the data. So the reason I say that is that in a way I'm getting the whole of the ACTs, road edges and everything else. So since I'm just explaining this, let me actually instead say I'm just going to put in the extended boundary, or in fact, I'm just going to put in, well, no, I'll put in those two boundaries, extended boundary and that one there. Press OK. Now, CMS is right, layer name is title. So what I've noticed is that in the Mac one, if I specify here a name, it doesn't let me come back to this dialog box to run it. So I have to create a separate temporary file. So I'm going to run that, and it's pretty quick. But what I want you to see that I'm doing now, if you don't have, you can create the file, great. I can't. So I'm going to now copy this path because I need to find this file. Now, what I want to do then is I want to get a browser up. And if I go to here and go Shift Command G, it offers me a path, and I go and paste that path in there, and out that I get that output, right? So now what I'm going to do is I'm going to actually put that in there. Now, these other ones that I had already, these other boundaries, I'm going to actually delete those because, you know, I'm about that one I've just exported is the boundary. So I'll move it in here. Good. Let's go back to Rhino and start this whole process again. So now we're going to go to a new model. What I'm going to do is I'm going to import, first of all, the contours. You accept all of these settings. Now it's, you know, it's still thinking. As we can see, 22,886 curves, right? Don't forget how many points that's going to have. So there's a lot of data. So now I'm going to go Z extents to show the whole thing. And we know from that previous example that whoops, there's stuff going on up there. So I'm going to again clip that. Let's trim again. Should be fine. Let's take that out. Let's look in perspective and see what we're looking at up there. How are our contours and stuff? Seem to be okay. Okay, now let's try to bring in this other one. See what happens with it. Okay, so you see what's happened is that, which is great, that those have now come in the right location because the coordinate system is the same. And you'll see also it's kept those layer names. So I could have also exported the contours in that way, but in actual fact, I found that there is a, you know, there is actually an issue with uh, with uh, an issue with how it deals with that file size, and it really churned for me. So I think it's useful to do the big files like that separately. When I've got those boundaries, now let's look at what we're talking about. Let's look at let's zoom out a bit. Let's go into perspective. Where are they, these images? You see they're down below, right? Now, what I'm going to do is I'm going to change some layer settings because they look different. So I start by saying selecting everything in the drawing, which will take a bit of a time. And at this point, when it says display color, I'm going to actually go to here and I'm going to say, I'm going to click on by layer because that's what we want it to do. Now it might churn because it has to kind of assign that value to everything, but I was kind of concerned that those two new layers that came in as black lines rather than as, red lines. Okay, so let's now say that the extended boundary, we'll just make that, green and apply. So we've got two, it's actually the wrong way around. That line there is actually not the extent, that's the suburb boundary. Good, the extended boundary is on the outside. Okay, next. So what we do need to do now is we need to actually go and we're going to use Grasshopper to create our surface. I've played around a bit because we had some issues in the last demonstration I did. So what I'm now doing is to try to make a more coherent and easier one. So first thing to note is that, you know, we've got a whole lot of curves here. So what I'm going to do to start with is I'm actually going to lock these two layers so that I can select, not worry about what I'm selecting. So because these are curves, we have to reference them into Grasshopper because the way that Grasshopper works is either it previews in Rhino or it takes data in from Grasshopper. And so what we're after doing is taking a parameter, and the parameter is the geometry. So if I type in curves, then what I need to do is actually I need to right click on them and then make this a assign those curves. And so if I go onto curve and I press right click and then I go to set multiple curves, I can then choose to select all of those. Now, because I've already locked extended boundary and suburb boundary, it's only going to get those contours. Now, the contours are referenced, and you can check their reference because when you click on them, they're green. Now, there are a whole lot of lines. And so what we need to do is we need to actually make out of those lines a another we need to make a surface out of them, and we extract information out of them. Now, after there's a few things that you can play with, but most of them will require you to utilize some points. So to get points, what I'm going to use is I'm going to use a component called control points. Now, when I go to control points, it says extract the NURB control points and knots of a curve, right? And so if I click on that and I type it here, if I was trying to work out where that was, it would probably be under curves under analysis, and it would probably be this one that says control points. Let's just check it's the same one. Yeah. Now it's going to churn a little bit when I do this because it's got to do some analysis. And you can see if we look, it's talking about what comes out of it is points. What comes out of it is weights. What that means, I'm not sure, and the knots. So I'm going to plug it in, and then I'm going to pause the recording quickly because this might take some time. So let's see. No, didn't. So I'm not going to pause it. But you can see how many points that is. Now, if we zoom in, you see there's a lot of points that are in there. It's all the points that are required to describe that geometry. And so what I'm going to do now is that the geometry what I'm going to use is something that's called patch. And this one I might have to pause it for. So patch, as it says, it creates a patch surface. Lots of variables here. Now, I'm not using the curves. I could use those curves themselves as the contours here to create that surface. Or I could use the patch, the points. So I've been using the points. So I'm going to do that, and this is where I probably will pause because it takes a little while. So I'm going to plug these in P to P. No, I'm not going to pause it right now. You see it's got some funny things going on. So that can be also because we need to flatten the curve. So now I'm going to flatten that. Now, flattening basically means that we're deparametricizing. It's like when you plug something in, it treats X, like in those curves, it treats each curve as an individual. Or each curve, sorry, is a version of the same thing. It tries to do the same operation on each one. Whereas we want to actually deal with them as a long list. So if I press flatten, it will probably churn at this point. And you can see it's churning. So I'm going to pause that for oh no, did it. Don't have to pause. That's good. So there we can see is the surface. Now, if we look at that surface, let's look at how close it is. Now, I'm going to actually de-preview the points so we can see the contours. If we look at it, we can see that there might not be a totally close approximation everywhere. It's an approximation. And so there are a series of variables that we can utilize to make this tighter. And those variables include the number of spans, they include the flexibility, particularly these two. Trim, I'm not entirely sure about. So I encourage you to play with that until you get a tighter curve. I'm not going to do it because it takes quite a bit of tweaking. I'm going to just accept this and do a few other operations. So when we're looking at this now, we can see that it's doing something, but it's sort of the reason it's bigger than we need it to be. So we've got that as a patch. Let's just bake it for a second and have a look at what that is. Now, baking is when we make it and take it into Rhino to see what it looks like. So let's go and just pop it onto a layer and bake it and then see what happens. And you see it turns up into a grid like that. It shows us that that's the grid. Now, if we're thinking about spans, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So when we see this one that says spans, we could say, okay, there you go. One locally defined value is 20. So presumably that's because there's one on either end, so 18 in between and one on the other side. So we could increase that to get greater definition, or maybe we'll try that. But you see that that's the shape it gets. Now, if you use a Delaunay mesh, which you can, it doesn't give you that nice definition. Now I'm going to delete this because again, we're working on the Grasshopper side. Now let me then go to, I'm going to create one where I'm going to go from, I'm going to say we're going from, since 20 was the default they were talking about, let's go to 50 as spans. So what I'm going to do is go to, instead this time I'm going to go to 30. I've created a slider there and I'm going to plug it in. Again, it might churn a bit further. So let's put this in and see what happens. It's going in there. It's now, it's putting a 10, it's actually essentially doubling. And you see it actually got a bit finer. So if we now look and zoom in there, we can probably see that this is getting a little bit finer about how it's dealing with stuff in here. We can still see there's bits of approximation going on. Let's bake that and have a look at that again. And you see there's the mesh, and you can see that logically speaking, it's going to get finer. So, keep playing until you get to the level of fineness. Now, when it comes to this thing about flexibility, it says here, flexibility, one locally defined value is 1. Low number, less flexibility. Higher number, more flexibility. Now, again, we can keep playing with that, but let's stick with that. Again, I'm going to take out that curve, that thing, because we don't really need it. We can see that it's getting a bit more into it. Like let's shade this for a second, see what happens when we shade it. We can see that there is a certain amount of detail in there. It's not the best shading we've got, but we can pick up some level of detail in there, and so I recommend playing with that until you get that to fit like you do. I like it because it's more of a uniform surface. It's not as distracting as when we get the Delaunay mesh, which is more accurate. And so I think this is, if we're just sort of playing in a way, we're not in a super accurate space, I don't think this is a bad way to go. And I think playing with these other variables is useful. So I'm going to take that out. Okay. So now what you can see is it's bigger than the area that we need. So what I'm going to do is now I'm going to put a curve on here, and I'm going to make that curve. I'm going to keep those together because that's now our group. And, it's in the habit of grouping. So I'm going to make that a group, and I'm going to call that the patch. Call it the contour patch. And now what I'm going to do is I'm going to actually I'm going to set one curve. I have to actually unlock these two. What I'm going to do now is I'm going to set the patch, or set one curve, and I'm going to choose this one here. Now we know what that is. That's the extended boundary. So I'm going to put a little name on it. Now the reason I don't change I did some training with McNeil and who produce this program, and they recommend doing this. So you can still see what the component's doing. It's a curve, but it's telling you what it is, So I've got that. Now I want to intersect this. Now I don't know what the distances we're dealing with are. If I drag a line, if I do a distance, we can't really see. Let's just do a distance. In fact, let's do a distance at the front. And a zoom extents. Let's do a distance where we just go from here to here. Let's ortho. That's one. It's obviously we're in meters here, 1,181. So I'm going to create a slider that goes from 0 to 0 to 1,200. Okay. So what I'm going to do now is I'm going to go back to where I was, and I'm actually going to, what I'm going to now try to do is clip these. So I'm going to clip this mesh from this, right? And so what I'm going to do is I'm going to choose the extrude function. If you haven't seen it before, extrude is basically asking for a base curve, which is this curve. And then it wants direction. Now, don't forget that you've got to tell it which direction you want to go as a vector. So because I want to go Z, which is upwards, I type in Z and I get to unit Z. At that point, what I'm doing is I'm plugging that direction so it knows, okay, I'm going upwards, and then I'm putting this in here. Now, there's no number there, but I'm going to go to pull it. I'm going to pull it right to the end. And you see how, this slider is changing that height for it. Now, that's just a useful thing to remember, that it always needs a vector, and vectors can be multiplied. That's a physics thing, right? So there we can see that's that line. Now, what we can do now is, what I'm going to do is I want to get the patch and I want to split it. So if I go split and I go split B-rep, so split one with another, I can say what I'm trying to do is I want to split this patch with this one. Now, out of that, we can see that we've got, something's happened. How many things have we got in here? It says 2 locally defined values. Now, obviously, we've got, if we, there's, because of those 2 values, we have to select one. So if I go to, I've used list item and it didn't work before. So what I'm going to do is, I'll see if it works this time. I'll put that in there. Yeah, it's like it's working, because you can see how that one is actually the outside is 1. So that's the outside, because when we split it, there's the inside and the outside. So obviously that's value 0, right? So what if I want 1? Well, what I can do then is I can try this. I mean, I had an issue trying this before, but if I type 1 in there, we get a different outcome. Now we've got the 1 on the inside, and that's what I want. So here, what I can do is I can turn off a few previews. So I'm going to turn the preview off so that we don't see that. Because we've got split, I want to turn that off as well. The extrude, I want to keep it enabled, but turn the preview off. Have I already turned the preview off of the points? I think I did. The curves, they're there. I can turn the preview off of those. But you can see how we've now got that surface there. Now, they're currently, the contours are still shown here. I could also turn those off. So then if I did, what we've done is just got that surface. Now, you could keep the contours on, but it depends in a way. If we want to work on the surface, not being distracted by contours is not a bad thing. So in a way, I've used that edge. So I can now turn the preview of that off. And I can also go in here and I can then say, we'll turn that off. So when I'm doing this, all I'm doing is recognize on the Rhino side, it'll still always show, even if you if you unturn the preview off on the Grasshopper side. So what I'm trying to do is just sort of manage what I can see at all times to keep it as simple as possible. You can tell that they're not previewing because their color is a different color. Now I've got to get another curve. Now, obviously, this is the external boundary. There's a whole lot of functions that happen there. So let's now actually gather those together so we know what we're working with. And let's move these things. Now, you'll see that number is actually like I've got a slider, but I really only just used a number. So what I could just as easily do is actually I could either create just a panel that has 1200 in it and plug that in, and it would do the same thing. Take that out. Or what you can also do is you can actually embed a value. In that case, what if I wanted to, you can do something that's called internalize the data, which means that it will just put the number of 1200 in there without me needing a slider. So if I do that, that's there and I can delete that, because in a way, all I needed to do was get the extrusion. I'm not really caring about how high it is because it's a constructive or a subtractive element. So long as it's taller than the mesh, all of the mesh, it has that effect. So now we've done all that. What I'm going to do is I'm going to do that and say that group that, and I'm going to call that trimmed patch. Okay, so we've got the patch and then we've got the trimmed patch. That's our working. Remember, we're working across here. Now I've got another one here. I've got another curve. So let me put in another curve here, and let's right click on that one and set one curve, which is this one. Now, obviously that's my SA2 boundary. So I go right click and I do that and I call that SA2 boundary. So I've got that there. We've got that surface. What I want to do is I want to put that, because that's a 2D geometry, I want to put that onto this surface. So what happens is I use a command called project, and if I type in there, you'll see project a curve onto a BREP. And so this edited piece of geometry is a BREP. That means boundary representation. And the reason that's good, better than a mesh, is that it's easier for us to work within a sort of a Boolean manner. So I go project, because these are all Boolean operations. It says, what do you want to project? Well, I want to project this curve. And then it says, what's your BREP? Well, it's this one. So you see now the curve is on that surface in 3D. If I wanted to, I could bake that, and you'll see that that curve is now on that surface. Now, this is a really important thing, and is also the end of our tutorial, because that means that when you're working in 2D, you can work in a live way to see how your geometry sits on the landscape. And so, in that we can now also, I can then turn that off, and so I can then say, let's turn the preview off, and I'm also going to go here and I can turn that geometry off. So now all I've got, hang on, I've turned that on again. Let's turn those two off. Or, we can see now I've just got that geometry on there. And so what I can do is just say, I'm just going to call this, projected SA2. Now I can still, this is not an endpoint. I can do other things in that way. If I wanted to, I can sort that boundary in different ways, and I can do different things. I could clip with that as well. What's nice is you can see how that boundary is starting to get inflected by some of the geometry and some of the surface, which is great. If we bake this one here, let's bake it. See what it looks like. That's interesting. Oh yeah, no, that's right. It's given us, there's the trimmed piece of geometry, right? So you can also see how, yeah, that's giving us that trimmed geometry. So I don't need to keep it baked, because I'm going to keep working on it. This is only the start. So let me now undo that, leave it like that. So yeah, in this tutorial, we've looked at how to get from the DEM all the way to a surface, which I encourage you to explore, and then how we can actually get to to project things on the surface, which allows us to coordinate between 2D and 3D and see the influence of topography. And as I said, if you're not happy with that surface, keep working on those intervals in here in terms of playing with the grid interval and the flexibility and how tightly it sits, until you find one that's a balance between processing power and how much time it takes to regenerate and work with it, and also the level of detail, which is what you're always playing with.